Pablaso, the architect, and Meg, the engineer. The two are diving headfirst into the design development stage of building design. Pablaso is a big deal, known for aesthetic designs that cost little to make. Meg is a Cal Poly grad and prior student of Dr. Baltimore's Arce 451 Timber and Masonry Design Lab. Can Meg manage to design an effective structural system for Pablaso quickly and for little pay?
Meg, this shear wall does not jive with my vibe.
What's wrong, Pablaso?
Everything. It's too long. Split it in half and be done with it.
It won't work that simply. The two walls will have nowhere near the same strength as a single wall of the same length.
What Meg is trying to convey is relative wall rigidity. If this was the original configuration of the walls, each with equal height, then each wall would take an equal amount of load. Pablaso wants to split one of the walls into two 10-foot walls. However, if we use the formula to solve for the relative rigidities of each wall again, we find that more load is now taken by the 20-foot walls than the 10-foot walls. Therefore, equal length does not mean equal forces.
But I need all walls to be on the west side only. The sun rises from the east and my design will be ruined without this layout.
Symmetry in our lateral force resisting system is incredibly important. Although Pablaso's request meets the minimum parallel wall force couple in order to resist rotation of the diaphragm, a three-sided diaphragm puts a much more complex distribution of forces to the lateral force resisting members. When designing quickly and for little pay, we would like to have our center of rigidity and center of mass to be relatively close together in order to alleviate the effects of that eccentricity and allow for a simplified design.
There has to be a rooftop garden. I must have it.
The addition of the soil load, extra seismic provisions, and drainage concerns will result in the project costing some more. My fee will rise by a boatload.
A tugboat load.
No, a cruise ship.
That won't do. Can we give our client some sun without robbing me of all my mun?
How do you feel about patios?
So why does the roof garden need extra seismic provisions? Well, let's look at this building in terms of lumped masses. For a building with floors of equal mass, the deflections would look something like this. As you can see, all the floors deflect in the same direction, which means that the building stays within the first mode. If we were to add a roof garden for Pablaso, the top floor would be significantly heavier. If an earthquake were to hit this building, the heavier top floor would make the deflected shape look something like this. This mass imbalance causes other modes to come into play, which makes Meg's job a whole lot harder.
We plan on using gypsum boards on walls. Looks nice and it works for your shear, right? Are we okay on this one?
We actually did a project in class about this. Gypsum board was better than walls with improper nailing, but just think of the longevity of your building with nicely nailed plywood walls. Proper nailing means smooth sailing.